Hello everyone, my name is Cedric Schulz.
I'm Patrick Lindwall.
And I'm Chad Martin.
And we are Group 3. Today we'll be discussing DP2 and what we've done so far. So, from what we've done since DP1, we basically created a progress plan. So basically gone along the Gantt chart. We still continue to stay on track, keep up with all our plans. We've done our customer needs identification, so that means we've done interviews, we've done customer profiles, things like that to keep us on track with our products. Next we have product specification identification, completed that as well, basically translating the customer needs into what that means for our product and the features we want to include. Then we have economic analysis. We also completed that recently. That's something that we created to basically show that our product is profitable and it's going to return money to VTEPs in the long run. We also did an intellectual property search, which basically means that we went and looked up patents to see if any had expired, then we could use them, or if we were going to infringe on them, we didn't want to infringe on copyrights, existing patents, things like that. And we also finished the concept generation, something that we did in class. That's where we use like the gallery method and just had people provide their input.
Alright, so this is the Gantt chart we've been using to track our progress. We're currently working on the product architecture, and like Cedric said, we just finished the concept testing and generation. After we complete that, we're going to work on the design to manufacture, economic analysis, prototype, and then finally the presentation of final results. So we're on track to complete this on time, and we plan to continue that.
So next we have the project management. This is what we've done so far since DP1, when we last left off at target specifications. So since then, we've gone into intellectual properties, like I said, looking up different patents to make sure we can use these certain ideas. Concept generation, of course, that was when we did the gallery method, get input, get a different set of eyes, maybe see something that we weren't looking at before. We've also completed our concept testing, which is when we went into the fifth lab and basically started building our mock-up just to make sure that everything was grounded, everything was in the right place, just bringing that to life. As you can see, we're going into product architecture pretty soon, which relies on a lot of the things that we have already completed, so we are on track for that.
So this is the intellectual property research we did. These are a few examples of the things we found that will affect our project. So what we did was we basically went and found patents that we could use ideas from that were expired, or patents that are current that we couldn't use the ideas from. So starting from this side, this is a manual ramp that we were thinking about using. It is hand operated, so allow the user to elevate the ball without the use of an Arduino, so you can free it up for use elsewhere. These two are similar in that they're connection pieces that we were thinking of using for a project, but if we wanted to, we'd have to license them out from Connects and Lego.
So this is our concept generation phase that I was discussing before. Basically, what our team did, VTEPs Group 3, basically came up with a bunch of ideas using the 635 method. Basically went around the table, got different inputs on different ideas. We were able to establish different processes for the same thing. So we all gained valuable input on what we wanted to do for our final product. So for example, like we determined that using a ramp to observe like the speed differences would be really helpful in basically describing the difference between kinetic and potential energy compared to maybe like the hammer method, which involves too many moving parts, things like that. So this was really a very effective project in order to ground our ideas and then put everything together.
So once we generated our concept, we were able to design, or we were able to create a failure modes and effect analysis graph to help us determine which parts of our design had to be modified in order to be successful. Our most prevalent form of error was the ramps becoming unaligned. The reason for this would be the glue holding them down would weaken over time or would be abused by the user. The cause of this failing would be a complete failure of the demonstration. The ball would fall off and nothing would happen the way it was supposed to. So this gave it a high severity. And the occurrence is 6 because it is very prevalent for objects in the classroom to be abused over time. And the detection, it is a low number. It is very easy to detect. You'll be able to look at it and see if the ramps are aligned or not. But it came out to an RPN of 84, which was by far our most significant failure. One way we could fix this is just by making the ramp stronger or making some sort of positive latching system that holds them in that would withstand the abuse of classroom environments. Our second most prevalent failure would be the elevator. With our current design, we realized that the ball could get stuck in the fan. This would cause the demonstration not to work and could cause damage to the fan. It could also be dangerous for anyone trying to clear the fan with their hand when the fan was still energized. Ways that we decided we could fix this were by putting a grate over the fan so that if the fan were not supplying enough flow or was off completely, the ball would rest on the grate and not go down into the fan compartment. Then our last failure mode we determined was the selection gate. The RPN was only 16, but it still is something that has to be addressed. The gate could malfunction because it is just a hinge, so if the hinge were to snap, the gate would fall off. The demonstration would still work, just not as designed, because the ball would not be able to be directed down which path. Ways we would fix this is just by making the hinging mechanism for the gate stronger, with stronger materials that are still affordable for our project. This is our economic analysis. It is very fund heavy in the beginning. For the first year, our product will not be sold. It'll be strictly in development phase, so all income needed will come from VTEPs. Towards the end of the first year, a lot of funds will be necessary because we're planning on ramping up our production. Then as we get into the second year, no funds will be required, but no funds will also be returned. Our product will be being sold, but at low numbers, and that money will be used into further development of the product and continuing to ramp up manufacturing. Once we're in the third year, lots of money will be returned to VTEPs. Most of the development and manufacturing setup will be done, and the product will be sold at a much higher rate, allowing us to return much more money back to VTEPs. All in all, this will have an annual return rate of 16% for VTEPs. And the returns, or the 16% is for the 3 diagrammed years here. If we were to continue on to sell the product afterwards, it will just be more revenue for VTEPs since most of the development will be completed.
Overall, we're completing the project on time, and we hope that our final product will be high quality, customer service centered, competitively priced, designed around our customers' needs, and released to the market within a given time frame. We look forward to your investment.